right, I'm going to try and keep this lesson shorter than 10 minutes since last night went a little bit over 10 minutes. I apologize again for that. Today is simplifying expressions, and I got to tell you guys, this is probably one of my favorite topics in math. I love everything about algebra. I think it's fun, and as long as you know the rules to follow, there are so many different ways you can solve these kinds of questions, and so I really enjoy them. On your next page in your notebook, go ahead and write the heading Simplifying Expressions and the objective I can combine like terms to simplify variable expressions. Remember, a variable expression is just a combination of variables, numbers, and operations. Operations like addition, subtraction, multiplication, and division. Okay, so we're going to learn how to make these things more simple by combining like terms. And trust me, when you have a really long variable expression, you want to make it more simple before you start trying to solve it. Otherwise, you're going to give yourself such a headache. So, just a quick review of some vocabulary. Do write these down. I know you've written them down a couple times already, but writing them down helps reinforce that understanding in your mind, and I will be looking for that in your notebook. These should be able to fit on the same page as your objective. So we have like terms, which are terms that have identical, that word identical is so important, variable parts. Identical means that, let's say I have 3x and 5x. Those two terms have the exact same variable part because both of them have the variable of x. Let's say instead that I have 3y and 4y squared. These are not like terms because their variable part, including that exponent, is not exactly the same. This would have to have a little 2 up here in order for them to be like terms. All right, coefficients, the next term is the number in front of the variable. So the coefficient of 4x is 4. It is not 4x. The coefficient of negative 3p is going to be negative 3, including that negative sign. And the last vocabulary I need to review with you is constant. Constant is any term in a variable expression that doesn't have a variable. So those are the plain old numbers like negative 3, 12, negative 16, etc. All right, so once you get those vocabulary terms written down, we're going to move on. And now we're going to talk about the steps for combining like terms. Let's go ahead and go to the next page for this, just in case you don't have enough room, and put the heading for that page, Notes. Step number 1 is first we are going to identify what the like terms in our expression are. And then after we identify them, we are going to add the coefficient, which is the number attached to the variable, but we're going to keep that variable just the same. And I'm going to show you a really kind of basic example of this. So our first step is identify like terms, and I have a variable expression right here. I have 3x plus 2y plus 4x plus 5y. So like terms, remember, are terms that have the exact same variable part. So if I look at my first term, my 3x, and I try and find another term that has that exact same variable. In this case, my variable is x. So the only other term that also has an x is 4x right here. So I have 3x and then I have 4x. So I'm going to add those coefficients. The coefficients are 3 and 4, and 3 plus 4 is simply 7. And I'm going to keep the variable the same. So it's going to be 7x. Okay, so I added my coefficients and I kept my variable the same. Now I'm going to find any other like terms I might have. So I have a 2y here. Notice I'm using a different color. That can be really helpful to kind of keep your variable expression organized so that you can make sense of it. You can use markers, highlighters, colored pencils, crayons, anything you need to kind of separate your terms into things that go together. So I have a 2y and a 5y. They have the exact same variable part. Their variable is y. And if I add those together, I'm going to add my coefficients 2 and 5. That gives me 7. And I'm going to keep the variable the same, y. I simply add those two terms together and I have my simplified expression, 7x plus 7y. These two variable expressions they mean the same thing. They are equivalent. And I would like to take just a minute to prove to you that they are equivalent. So if I have my 7x plus 7y, let me go ahead and erase all of these extra notes, extra marks so they don't confuse you. Let's say that I am going to have you evaluate this expression. And I'm going to say that x equals 1 and y equals 2. Well, you guys learned how to evaluate these variable expressions, and you did it by substituting and then solving. So if I plug 1 in for x, this is going to be 3 times 1, and then plus 2 times my y value is 2, plus 4 times x, which is 1, plus 5 times y, which is 2. Okay? If I then go ahead and simplify that, 3 times 1 is 3, plus 2 times 2 is 4, plus 4 times 1 is 4, plus 5 times 2, which is 10. Add that all together, I get 7 plus 4 plus 10. Hang on, I need a little more room because I write too big. What else is new? 7 plus 4 is 11, and then 11 plus 10 is 21. Now let's see if we get that same answer when we take our simplified variable expression up here and substitute the same values for x and y. So I'm going to be substituting here. I have 7 times x, which is 1, plus 7 times y, which is 2. Well, 7 times 1 is 7. 7 times 2 is 14. If I add those together, I get 21. So I've just proven to you that when you combine like terms and when you do it properly, you get an equivalent variable expression. Okay, does that make sense to you guys so far? I hope so. I think you are prepared to understand this concept. So, some special notes. We have to always turn subtraction to adding the opposite. I've said this 1.5 million times. I want you to write these special notes down and remember them. If I have subtraction in a variable expression, turn it into adding the opposite. If a variable in your variable expression doesn't have a coefficient, we assume that the coefficient is 1. And we assume that because mathematicians are lazy, and if it's a 1, they're just not going to write it. Also, all constants, all numbers without a variable, are considered to be like terms, and they should also be added together. So let's real quick do another example for you. Remembering those special notes that we just wrote down, we have 3a plus 2c minus a minus 2 plus 4c minus 5. Whew, that's a long one. Let's first turn all subtraction into adding the opposite. So I'm going to keep 3a. 2c can stay the same too, but now I have subtraction. So instead of subtracting a, I'm going to add negative a. Instead of subtracting 2, I'm going to add negative 2. And then I have plus 4c, and then minus 5, but I have to get rid of that subtraction, so I'm going to turn that into plus negative 5. Okay, another special note said, if a variable does not have a coefficient, the coefficient is 1. We have one situation like that here, this negative a, so that is actually negative 1a. All right, are you with me so far? Oh, I have 30 seconds. I can do it. All right, so I'm going to find like terms. I have a 3a here. I'm looking for an identical variable part. That's going to be my negative 1a here. I'm going to add my coefficients. So I have 3 plus negative 1. You should know your rules of integers. 3 plus negative 1 is going to be positive 2. So that is simply going to be 2a. Let's find another set of like terms. I have 2c there, and I have 4c. If I add those together, that's going to be 6c. And now let's see if we can find any others. I have a -2 here, which is a constant, plus -5, which is another constant, so those are like terms. Over on the side, I'll just write -2 plus -5. Remember your rules of integers, they have the same sign, so I find the sum, 2 plus 5 gives me 7, and I'm going to keep that negative because they're both evil, so I have lots of evil soldiers. So I'm going to add that on plus -7. So my final simplified expression is 2a plus 6c plus -7. And you are done. You can see that it's a lot more simple than this original variable expression we had. Okay, for your reflection, I want you to attempt to simplify this variable expression right here. Put your response in Edmodo when you turn in your assignment, and I can't wait to see what you guys come up with. All right, have a good night, guys. Bye.